Example 1. Please derive an equation to calculate the entropy change of n moles of an ideal gas undergoes isothermal process at temperature T. The initial volume is Vi and the final volume is Vf. Hint: first law of thermodynamics. Well, since we want to calculate the entropy change, one starting point is to use the definition of delta S. This is the definition of entropy change. It is defined as Q reversible over temperature in Kelvin. Q reversible represents the heat during a reversible process. Well, since the hint says we need to use the first law of thermodynamics, let's put down the first law of thermodynamics. This is the first law of thermodynamics. The change of internal energy is equal to the heat plus the work during the process. I want to emphasize this is a universal relationship. That means it applies to any process, including isothermal reversible process. Therefore, we will get delta U equal to Q reversible at temperature T plus W reversible at temperature T. Well, since this is an isothermal process, delta T is equal to 0. We also know that the internal energy is a function of temperature only for an ideal gas. Therefore, if delta T equals 0, delta U must be also equal to 0. Then we can get Q reversible at temperature T plus W reversible at temperature T equals 0. Then we can get Q reversible at temperature T equal to negative W reversible at temperature T. If you recall, we know the work for an isothermal reversible process. Therefore, we can get the expression of Q reversible process at temperature T. Since we know the expression of Q reversible T, we can plug it in to this definition of delta S. Then we can get the expression or equation for the entropy change during an isothermal process. T and T will cancel. Okay, this is the equation to calculate the entropy change for an isothermal process. But some of you may ask me, Dr. H, the problem does not say it's an isothermal reversible process. But when we derive this one, we use an isothermal reversible process. So, is there a problem here? No. Let me emphasize, we know that entropy is a state function. Although we use an isothermal reversible process, but because it is a state function, it doesn't matter what the process is, as long as you specify the initial volume, the final volume, and the temperature. The entropy change will be the same. That's a good property of state functions. Well, let me use this problem as an example to explain the difference between general chemistry and upper-level physical chemistry. If you recall, we have learned 3 qualitative rules to predict the entropy change during a process. One of the rules says when we increase the volume of a gas, the entropy increases. Can we get the same conclusion from this equation we just derived? Yes. When the volume of a gas increases, the final volume is larger than the initial volume. Therefore, the ratio between Vf and Vi is larger than 1. So, the natural log of Vf over Vi is positive. Therefore, delta S is positive because both N and R are positive. If delta S is positive, the entropy of the final state is larger than the entropy of the initial state. As we can see here, in upper-level physical chemistry, we will derive an equation. And in general chemistry, we will use the conclusion from the equation we derived from upper-level physical chemistry. I hope you will understand the difference between the general chemistry and upper-level physical chemistry.